This is a presentation sharing some of the work that I've done for a friend of mine to bring a little magic to his life using IoT, or the Internet of Things. There's a little bit of background. This buddy of mine, Adam, and his wife, they bought their first home a couple of years ago, and they're huge Harry Potter fans. And they decided in the basement of their house they were going to build a Harry Potter bar. And in that bar, not only just setting it up and decorating it like Harry Potter, but they're extremely artistic, and they created some storefronts. It's a little hard to see in this picture, but this is an actual picture of what they've created. They've created two storefronts in the spirit and looking like some of the stores from Diagon Alley or Hogsmeade. One is Twilfit and Taddings, I think. If I have that right, I'll just refer to that as T&T. That's on the left. There's a door to that store in the middle, and on the right is the ice cream shop. And they came to me and they approached me and they said, "Hey, we know that you love tinkering with Arduinos and making things happen and animating things and with those Arduinos. Could you do anything to help us make our Harry Potter bar any cooler than it already is?" So we sat down and we put our minds together and we started thinking about what we could do. And after brainstorming some ideas, we came up with two fundamental capabilities that we wanted to implement. One is the ability to sense when someone is looking in one of those windows, and to have something within the windows occur just because someone is looking in. And the second is to be able to trigger something to happen, be it lighting or an action to happen inside the scene or sound to play, based upon a magic spell issued by someone in front of the window. And one of my goals was to implement a modular design so that we could create individual modules that would function individually and had very specific capabilities in mind that we could plug together, so to speak, using IoT, and they could communicate with each other to trigger and make these things happen. And you'll see more about that as we go along. As a result of the work that I've done, that's resulted in 6 IoT module types, which we'll go into in detail in a little while. But there's 2 main types. There are sensors, which are the ones that sense that things have happened. And then there are actuators, which cause things to happen as a result of what's been sensed. Now, there are 6 modules, as I talked about, but there is some common functionality that I wanted to have in all of them. And that's what this slide talks about. It talks about common properties that they all support and the events that they all either publish themselves or that they react to when they receive those events. So some of the properties, obviously some important ones are to know the credentials to access the local area network on which they're running. Then there's a technology called MQTT, which is the event protocol that allows all these devices to communicate over the network. And we need to know where the controller is, and I'll talk about what the controller is in a minute. Where we need to know the IP address and the port of where the controller is that's controlling everything that's going on. Each device appears in a scene, so that in the T&T store or the ice cream store, those are scenes. So each device appears in a scene, and it has a unique device name within that scene, and that's what uniquely identifies each module. And then there's a service port that is, again, off of the controller, which is necessary to be able to look for software updates if I make changes to the code without having to plug them into my laptop and actually deploy the code. That way I can actually do the updates over the air, and that's what that service port is for. You heard me mention the events, and the idea behind this whole thing is that they publish and subscribe to events. So that when something happens, they'll publish an event so that anything that cares about that event will act, and they subscribe to events, these modules, so that if they receive a specific event that they care about, they will receive that event and they'll take action accordingly. So here in the middle, I talk about some of the common outbound events in all the modules, right? The module will send a notice back to the controller that they are ready, and they're ready to begin accepting events. It'll send back a notice that it has started, and which really means enabled. So there's a concept of starting and stopping a node, which is enabling or disabling it, so that it can receive events or stop receiving events at any given point in time. So that's what started and stopped are. Running indicates that it is in the process of running the action that it is programmed to do. Triggered is the first event that happens before it's running. The triggered event says, oh, I've been triggered, I'm about to do what I'm going to do. It then publishes the running event while it's running, and then publishes the done event when it's finished doing whatever activity it's meant to do. And this will make a whole lot more sense in a little while. The inbound events that they all support include start, meaning enable yourself so that you can start taking action, stop yourself from responding to events. The go transaction or the go event is there really as the trigger event to say, hey, do what you're supposed to do. And then from an administrative perspective, there's a config event, which if it receives a config event, it puts itself into configuration mode, turning on its web server. Each device has its own web server built in that allows me to go in, or anybody to go in and configure how it's meant to run. And then there's a check event that it subscribes to, and the check event will tell it, hey, there's a software update that's been made available for you. Go out and check if it's there, and if you see it in the controller, download it, install it, and begin running it. And that allows me to do the updates over the air rather than having to hardwire into a computer. You heard me mention controller. The controller's really main job is to orchestrate all the events and dictate what happens when an event occurs and tell other nodes what they should do in response to an event. It's a Raspberry Pi. It's running a platform called Mosquito, which is the MQTT platform that supports all the events. It's also running an application called NodeRed, which is the programming environment to program the logic behind what happens when an event occurs. And you'll see a rendition of that. I'm not going to go into the detail about how that works, but you'll see what that kind of looks like in a little bit. As a controller, it receives events from modules as those outbound events that we talked about happen, and it sends events to modules to tell them what they need to do. And by doing that, it controls which activators to trigger based upon the sensor events that have occurred. So now we'll talk about each of these sensors. This is the first one, which is the IR sensor module. And besides the common events and properties that we saw before, the IR sensor, because its job is to sense when a particular IR code, like you might receive from a remote control, TV remote control, it needs to know what code to look for. And that's what the IR code property is meant for. And it has a separate event that's a triggered event because it's a sensor that says, if I receive that code, I'm going to publish the triggered event so that the controller knows that I have received that event and it can do what it needs to do. Similarly, there's a proximity sensor module, which senses when someone is standing in front of it. And it also publishes a triggered event, but it triggers based upon someone standing within a given range of that sensor. There's also a range check delay property, which is just a delay to say, okay, after you've detected someone is in front of you, how long should you wait before you check again? That way the action that's happening as a result of someone standing in front of it doesn't necessarily happen continuously. It can happen at a random interval between checks. There's a servo module. Now this is one of the actuator modules. The servo module drives a motor, a servo motor. And a servo motor is a motor that can be turned to a specific number of degrees at a specific speed. And so as a result, the properties it has a bottom and top, which are the starting position and the furthest rotational position where it's to rotate to. There is an up speed, which is the speed at which is to rotate. Should it rotate slow? Should it rotate fast? And then there's a pause, which says that once the motor rotates to the top position, how long should it pause there before it returns back to the bottom? And the way a servo module gets triggered is through that standard event called the go event that we talked about earlier. There's a relay module. The relay module is a simple one in that it's really just a switch. It turns on a device or turns a device off. So it has only one additional property, which is pulse seconds, which I'll talk about in a minute. But the events that it has, it receives an on event saying turn on the device that you're connected to. It can accept an off event, which will say turn off the device that's connected to you. And a pulse event, which says, okay, turn that device on for a given number of pulse seconds, and then turn it off once that time has expired. Sorry about my dog. There's an RGB module, and as you can probably guess, an RGB module drives an RGB light strip. So it has events to say, set your light strip to a specific RGB value, or set it to white. It also has the capability to fade from one color to another. So there's a fade RGB event and a fade white event, which will say fade from whatever color you're currently at to that new color. And then lastly, it receives an event to turn itself off. The only new property that has is called a fade delay, which controls how quickly the module fades from one color to the other, whether you want it to happen very fast or whether you want it to happen slower. And the last module is an MP3 module. And this module, as you can probably guess, plays MP3 sounds or songs or whatever it needs to play. There's no additional properties that it has, but it does accept some new events. The play number event tells it to play the MP3 file that has a specific number that's loaded on an SD card inside the module. There's an end play event which says end playing whatever it is you're playing at the moment. So if it's playing a longer track, you can tell it to stop playing. And there's a set volume event that tells it to turn up or turn down the volume to a specific level to the connected speaker to the module. This is a diagram, and I know it's a bit of an eye chart, but this is a diagram that shows what I'm going to show you a little while in reality in a demo. But this shows all the modules as laid out. Shows the controller in the center. The controller receives the events from the sensors, from either the IR or the proximity sensor, and then sends events to the other modules to take action based upon the logic that's implemented within the controller. And then lastly, there's a UI that I created on top of the controller that really provides a couple of capabilities, like being able to test and verify that everything works, but also to override whatever is happening in any of those modules, and you'll see that a little later. This is a screenshot of that programming tool I mentioned called NodeRed, and it depicts for you there in the center. The way it works is you define nodes, and these nodes represent various steps or events or logic, and you connect those nodes, and when you put them all together, it results in logic that gets triggered based upon an event. And that could be a whole presentation in and of itself as to how I have that all configured. And the last slide is the user interface. You can see here's just two small screenshots. I'll show some detail about how this actually works in practicality. But on the left is a screenshot from my phone, and on the right is a screenshot from my iPad, showing how it's a responsive UI, and the intent behind the UI allows you to change any of the settings, test the modules, and really affect any scene and any module and any scene that you want at your discretion whenever you'd like to. So that's some of the background. I know that's kind of the boring part, but I figured it's important to understand that before I get into the actual demo of it, which I will do next. So stay tuned. Thanks.